right, let's dive in. Have you ever looked at a calendar and just thought, why is it like this? Well, it turns out our clocks and calendars aren't just a random jumble of rules. Today, we're going to pull back the curtain and find the surprisingly simple, kind of beautiful math that's hiding in plain sight. I mean, we've all wondered about this stuff, right? Why is February the weird short month? And how come your birthday hops around the week every single year? It feels random, but I promise you, it's not. There's a hidden logic, a code. And by the end of this, you're going to know exactly how it works. Okay, so let's start cracking this code with the first big piece of the puzzle, the leap year. We all know what it is, right? But the full story, the why and the how, that's where things get really fascinating. So why do we even have them? Well, it's because the Earth is a little messy. It doesn't take exactly 365 days to go around the sun. It takes about 365 and a quarter days. Now that little quarter day doesn't seem like a big deal, but after 4 years, poof, you got a whole extra day. If we didn't do anything about it, our seasons would start to drift. So we stick in February 29th to get everything back on track. But here is where it gets super clever. It's not just every 4 years. There's a more precise rule, and this is it. Step 1, you know this one, is the year divisible by 4. Easy. But step 2, this is the exception that trips everyone up. If it's a century year, like 1800 or 1900, it also has to be divisible by 400. That's why 1900 was not a leap year, but the year 2000 was. That tiny little tweak is what keeps our calendar spot on for thousands of years. All right, you've got the leap year rule down. Now get ready for the master key. I'm telling you, this one simple idea unlocks pretty much every calendar calculation you can think of. It's called an odd day. And I know, it sounds a little weird, but stick with me. It's so simple. You just take any bunch of days, divide by 7, and whatever's left over, the remainder, that's your number of odd days. It's literally just the leftover days that don't make a full week. That's all it is. Okay, so here's where it all clicks. Think about a whole year. A normal year has 365 days. You divide that by 7, you get 52 full weeks, with a remainder of 1. So a normal year has 1 odd day. And a leap year, well, it has 366 days, which means it has, you guessed it, 2 odd days. So bottom line, a normal year pushes the week forward by 1 day. A leap year pushes it forward by 2. That's the foundation for everything. All right, enough theory. Let's have some fun with this and put this powerful little tool to the test. We're going to see this odd day thing in action and give you a kind of calendar superpower. Here's the challenge. Let's say today is a Tuesday. What day will it be 73 days from now? Now, you could pull out your phone and just count, or you could use our new trick and solve it in like 5 seconds. Let's do that. Okay, step 1, we take our 73 days. All we care about are the leftover days after we take out all the full weeks. So we divide 73 by 7. That gives us 10 full weeks, with a little bit left over. And those leftovers are the only thing that matters. And there it is. The remainder is 3. So in 73 days, you have 10 full weeks that don't change the day of the week at all, plus 3 extra odd days. This means the day of the week is only going to shift forward by 3. So the final step is super easy. We started on a Tuesday and we just count 3 days forward. So Wednesday, Thursday, Friday. That's it. That's our answer. See? So simple once you see the logic. Okay, so you've basically mastered the core logic of the calendar, which is awesome. Now let's unlock a few bonus levels and look at some other incredible tricks hiding in our timekeeping. Here's a cool party trick, finding the angle between the hands on a clock. Let's try 7:20. First, just look at the numbers. The hour hand is on the 7, the minute hand is on the 4, right? That's a 3-hour gap. A clock is a 360-degree circle with 12 hours, so each hour is 30 degrees. So 3 times 30 is 90 degrees. But wait, the hour hand isn't sitting exactly on the 7. It's moved a bit, so we just take half the minutes. Half of 20 is 10. And since the minute hand is behind the hour hand, we add it on. 90 plus 10 gives us 100 degrees. Now, get ready for this, because it's going to blow your mind a little. Did you know that the calendar you're using right now isn't unique? You can actually reuse it. Yeah, if this year is a leap year, you can pull out this exact same calendar in 28 years. If it's the year after a leap year, it repeats in just 6. There's a whole predictable pattern to it. But you gotta watch out for that century rule we talked about. It's the ultimate curveball. Say you tried to reuse a calendar from 1872, which was a leap year. Normally, it would repeat in 28 years in 1900, but it wouldn't work because 1900 skipped being a leap year. That's a classic bit of trivia that gets everybody. So let's bring it all home. What's the big takeaway here? It's that the system we use every single day to track time isn't some random, clunky mess. It's actually a really beautiful, predictable machine built on logic. We've seen how leap years are this really clever fix to keep us in sync with the universe. We've unlocked the odd day concept as the master key to pretty much all calendar math. And we've proved that from figuring out a day in the future to the angle on a clock, it all follows a simple, predictable code. We've cracked it. And that kind of leaves you with one big question, right? We invented the calendar, this logical system, to make sense of the cosmos. It really makes you wonder, what other parts of our daily lives, our routines, follow a hidden logic, a secret rhythm that we just haven't figured out yet? Something to think about. Thanks for watching.